Okay, it's doing its thing. At least I hope it's doing its thing. All right, let's do the problem that we have left to do. Then we're going to go through your old exams, and I'll show you what I have so far. Let me move don't need this. And share, and then Ladybug. And oh, and you guys use the chat box a lot, so I need to have that. I have my new glasses, so I actually can see better. Wow, not so blurred. They sent a text message to my landline. I don't think that works very well. And now hit the recorder on the Ladybug. So we're recording, we'll have at least something, if not everything. So this is the problem that was left. And I kind of left it for today because it's kind of different than what I do with this other paper. What you're used to. And this is an infinity to the zero form. So what we did yesterday is we're going to infinity. So x is infinity. 1 over infinity is 0. It's infinity to the zero form, which makes no sense. It's also an indeterminate form. So being an indeterminate form, you got to do something with it. So this is the game that you have to play. And it's the game. Because this limit doesn't have any meaning, I can't use L'Hopital's rule on it because L'Hopital's rule requires either an infinity over infinity or a 0 over 0. I can't rewrite this as it stands to be either of these two forms, but I can do this. I'm going to let y be equal to x to the 1 over x. Then this is something that I know is true. So y, the natural log, take the natural log of both sides, the natural log of y is equal to the natural log of the left-hand side is equal to the natural log of the right-hand side. Now you could use any log you like. We tend to use more natural log than anything else. Then as I look at this, I could say, well, then if these two things are the same, so we know that y is equal to x to the 1 over x. If I take the natural log of both sides, they're still the same. If I take the limit as x goes to infinity of the left-hand side, but if I do it to the right-hand side, that's still the same. Too many humps. Humps in the limits and humps in the natural log. Now, what does this have going for us? Well, this is natural log of x. What this has, x to the 1 over x. What that has going for us, I just smeared everything. Of course, that's because I'm videoing, you know. Is that I can now deal with the natural log. This is the same as the limit as x goes to infinity of 1 over x natural log of x. Well, if I put infinity in, this is 1 over and this is 1 over infinity. This is a natural log of infinity. Now I have a 0 times infinity form. However, if I rewrite this as the limit as x goes to infinity of the natural log of x divided by x, guess what we get? We get the natural log, too many humps, of infinity over over infinity. Well, that's just an infinity over infinity form. Now I can use L'Hopital's rule. So aren't you glad you weren't a math major? Well, what is this now? I can take the derivative of the numerator, derivative of the denominator. The derivative of the numerator is 1 over x. The denominator is 1. Then I can take the limit of that, which is the limit as x goes to infinity of just 1 over x, which is 1 over infinity, which is 0. So that goes to 0. So what do we know? We know that the limit as x goes to infinity of the natural log of y is 0, because that's where we started with. We started with this guy. We determined t 0. Now, since you're not math majors and you're not STEM people at all, though some of you will be taking a great deal of math, if you're in economics, if you're in finance, if you plan to become an actuary. I have a student that's moving in my 150 class that's moving that direction. She wants to be an actuary. You'll probably be taking more math than even some that I took as a math major, taking a lot of math. You'll run into this kind of stuff. Well, I can interchange, I can bring the limit in with y. Well, what do we know that y is? Well, y is x to the 1 over x. I have something I can actually solve because the natural log of x is just log base e. And now just rewrite. So the natural log, whoops. I told you too many L's with humps. E to the 0 is equal to the argument. So the limit as x goes to infinity of x to the 1 over x equals e to the 0, which is 1. And no, 1, this is not going to be on the final. I know that's a question you would ask. So the answer is no, it's not going to be on the final. But who knows what you're going to run into as you go along. When you end up with these weird oddball things, like the infinity to the 0 power, you end up with these manipulations. And especially, you're probably going to end up with infinity to the 0 power. You're going to end up having to use a logarithm. And that's what you had to do with this problem. And it is not natural to think about doing it this way, at least not for most of us. It wasn't for me. How did I learn it? Because at some point in time, I had something in my set of notes that said this is what you could do if the pattern was an infinity to the 0 or a 0 to the infinity, that I could use natural log. Then I knew how to work the problem. Could I come up with this on my own? No. Is this the only way to get the answer? Unfortunately. Yeah, because you've got to get, and here's the key. Because you're looking at this, right? The exponent has a variable too. In order to make this work, because remember, L'Hopital says infinity over infinity or 0 over 0, I've got to find a way to bring the exponent down. That's the only way I'm going to get it into one of these two forms. And the way you get, how do you bring the exponent down? Logarithm, properties of logs. That's the only property that we know of that allows you to bring the exponent down. So unfortunately, yeah, is this about the only way to do it? Yeah. And it would be very, very hard to do it on your calculator. You know, because you're going to 1. How do you know you're not going to 0.9? Now, whether or not some of these sophisticated programs can do it or not, I don't know. I haven't tried it in some of those. I might try it and see. Some of these algebraic programs, computer generated ones, whether or not it could do something like that. You cannot bring the exponent down other than using natural log. Now, there's no way you can skip the natural log step, because natural log is the mechanism that you use to bring it down. So the problem is that's what enables you the properties of logarithms to bring it down. So there's no avoiding the natural log. Algebraically, there's no avoiding the natural log. Would be nice, but see, that's the key to what process you need to use. That says, because I know I need to bring the exponent down, the only tool in my toolbox that can do that is the logarithm. That's the only tool that allows me to bring the exponent down. So that particular key is what tells you what process you need to use. That's kind of where it's at on this thing. Yeah. So if I had to look to say as a math major, if when I see something like that, I say I've got to bring the exponent down, that says, what's the tool in my toolbox that lets me do that? Logarithm. So then I would ask myself, would the logarithm work in this case? And then I'd have to try it to see if it would work to give me what I needed. So yeah, that's kind of end up being the, how would you know how? That says I got to get this thing out of the role of an exponent, bring it down. And that's the only thing I could think of that we have in our toolbox that we can use. Yeah. So that's why I wanted to leave the problem to today, because I didn't want you to get all tied up in all this stuff. But you need to have seen it. I do not know how much Almadou will be involved in something like that, or the 218. The shame of it all, from a 218 standpoint, we had a gal who taught just completely online 218 class. Superb. God, students just loved her and just loved it. And but unfortunately, she moved to Colorado. She did it long distance for a while. Then she went back to school. She decided to get her PhD. So, and so, which point she quit teaching for us. So, but she did a tremendous job. I can't say that so much about the person who, I don't know who's doing it now, but it can't be near as what the job that she did. She was just terrific. Okay, let's go to your tests now. That finishes the course. And I've put together this sheet. I need to cross check it to make sure. I think this is the new one because it says spring 2021 on it. But I need to go back through while I'm going through with you. I'm going to cross check the sheet. I'm going to cross check it again before I send it out to you. And I'll also post this sheet and then send it out. But this way, if you have your test, you can mark your tests as well, so that we can start the questions tomorrow. And like I said, I've got another review coming. So I think I've gotten to derivatives. So where am I right now? I'm on I'm on a second test right now, heading to the third. So we're getting there. We're not quite halfway there yet. On test number 1, most missed problem on the test is, and this is you're held responsible for, is problem number 2. So test number 1, problem number 2, that's your limits from a graph. And there's certainly one of those. So that would be problem number 2, no problem number 3. Problem number 4 is your limits. Now these guys here, they will include L'Hopital's rule. So any of these that we did using algebra, you can use L'Hopital's rule, or if you choose, you can use algebra if you can't use L'Hopital's rule. Things involving E, you're not going to have a choice. You have to use L'Hopital's rule. So all 4 of these, and there are how many limits? There are 4 limits. So these are 4 here. There are 4 on your test, but they also include the exponential functions and log functions, exponentials and logs. And of course, anything with a variable, you can use L'Hopital's rule. And remember, L'Hopital's rule, LHR, is only if you've got something of the form of infinity. You plug it in, it's infinity over infinity or 0 over 0. That would be, say, this guy. If you put infinity in, you get 5 times infinity squared plus 2 times infinity minus 7 over 2 times. Now, I would not necessarily use L'Hopital's rule on this guy, but what am I going to get? Well, this is going to be infinity squared plus 2 times an infinity minus 7. So this is an infinity over infinity form. That's L'Hopital's rule. So that would mean in order to do this, you would take the limit as x goes to infinity, the derivative of the numerator. So using L'Hopital's rule, the derivative of the numerator is 10x plus 2. Derivative of the denominator is 4x. And then I put it in again, and I still get infinity over infinity. This is why I wouldn't use necessarily L'Hopital's rule on this problem, because you have got to do it more than once. The limit as x goes to infinity, the derivative of the numerator is 10, derivative of the denominator is 4, and so this is 5 over 2. Now, for me, because I do so much college algebra. I mean, I always have college algebra in my schedule. Now, I don't know how long it's going to last, but I always do. And if I take a look at the quotient of the 2 highest powers, remember the model? This is 5x squared over 2x squared, which is 5 halves. Now, when I take the limit as x goes to infinity of 5 halves is 5 halves. That would be an alternative way of doing this particular problem. So you can use algebra on it, or you can use L'Hopital's rule on that problem. And here you plug it in, you get a number. And you can't use L'Hopital's rule on something when you get a number because that's what your answer is. Now, where you'd be forced to use L'Hopital's rule if I took the limit as x goes to infinity of x over, is that what I wanted? Yeah, e to the x, which is infinity over e to the infinity. That's an infinity over infinity form. So now I would use L'Hopital's rule because you're forced to. So this then becomes the limit as x goes to infinity. Derivative in the numerator is 1. The denominator is just e to the x. So this becomes 1 over e to the infinity, which is 1 over infinity, which goes to 0. So you have no choice. The L'Hopital's rule, the L'Hopital problem, that's what this guy is. So you don't have a choice. Yes, Justin? No?
It was accident.
Oh, okay. Either that was happening or you were snoring on the other side, so. Or your puppy was growling. Okay, so here we go. So that's that kind of thing. So they could either be algebra or they could be L'Hopital's rule. And you would use L'Hopital's rule. And I think that it says use L'Hopital's rule where appropriate. So this one is either. This one is no choice. You have to use L'Hopital's rule. Something like that. So that's problem number 4. And yeah, you get the same answer. Yeah. Well, here I did it using the L'Hopital's rule. I got 5 halves. Here I used the model. That's algebra. I would get 5 halves. The same as here. So negative 3 halves gives me a 0 over 0 form. If I choose to use algebra, this is 2x minus 3, 2x plus 3 over 2x plus 3. 2x plus 3's divide out. So that then becomes the limit as x goes to negative 3 halves of 2 times negative 3 halves plus 3, which is negative 3 plus 3 or 0. I hope. Oh, the plus 3's went. I thought that might, the answer is negative 6. So this is a negative. Would be a negative 6. Now here I could use L'Hopital's rule because it's a 0 over 0 form. This is the limit as x approaches negative 3 halves of derivative of the numerator is 8x. The derivative of the denominator is, oh, okay. The derivative of the denominator is 2. So if I take it, the limit as x goes to negative 3 halves of 3x, this would be 3 times negative 3 halves. Okay. 3 halves. Yes, I want my new glasses. 2 into this is not 3. It's 4. I can't blame my glasses for that. So this is 2 times -3, which is -6. Except for calculation errors, you'll end up with the same thing. Here I'm using L'Hopital's rule. Here I'm using algebra. Either way. To me, L'Hopital's rule is a little bit easier than the algebra is. And of course, problem number 5. You can't use it on every question. You cannot use L'Hopital's rule on every question. You can only use it on questions that have an infinity over infinity or a 0 over 0 form. If it's not either one of those, you can't use L'Hopital's rule. Yeah. You know, if I had a 2 over 0 form, well, that either this goes to infinity. If I had a 0 over 2 when I plugged it in, that goes to 0. So you can only use it whenever you plug it in, and you get one of those two things. So plug it in, number in, number out. 0 over 0, infinity over infinity, L'Hopital. So no matter what, you're going to have to plug it in. And then you make your choice. Problem number 5. Of course, it's all of them. They're just derivatives. They're your basic derivatives. Derivatives, this includes both exams. This includes all the exams for which there are derivatives. There are 5 derivatives. So you look at this 1, 2, 3, 4, 5, 6, 7. It has to include the second derivative. I'm going to choose 5 from all the derivative problems. So you'll have basic, you have product rule, quotient rule, chain rule, product chain, chain quotient, and of course then the second derivative. And then that is the end of the first test. So the last 2 problems are 5 and, oh, don't forget 6, second derivative. There are 5 derivatives total on the whole test. That covers everybody. I can put a lot in one problem. So for test 1, we're looking at problem number 2, all. Problem 4, of course, all. Anytime 5 and all. 6, all. Second test. I don't know that I think this was a preliminary key, what I can find. On the second test, that's chapter 3. Problem number 2, that's your absolute max min. There is one absolute max min problem. Question number 4, I'm not asking you to graph anything, but you need to be able to give me increasing or decreasing, concave up, concave down. So it would be for everything but the graph. And problem number 5, the same thing. Of course, there was no graph to this. So that would be problem number 5. And there is one max, min, increasing, decreasing, concave up, concave down. And there's one absolute max, min. So problem number 5. So on the second test, we're looking at problem number 2, 4, except for the graph. And 5. On the, yeah, this is actually the key to the last, or to the chapter 4 test. And on this test, problem number 1, these are all the derivatives in that incorporate the natural log and e. So of course, 1 all. See, this is where we actually needed, would have actually needed, L'Hopital's would have been, is this the one? No. Because he does not have a horizontal asymptote. Yes, he does. But he was okay. We wouldn't have needed, a lot of the problems we worked on, we would have needed L'Hopital's rule, but we didn't. But we're looking at problem number 1. And problem number 5, that's absolute maximum. So on this test, we're looking at 1 and 5. And this is on the chapter 4 test. So we're just narrowing it down because there's a lot of content. This last test with this integration, problem number 1, and that was basic. Problem number 2, that was U sub. And there was a problem in there that used algebra. So 1 and 2. Problem number 4, definite integral. Problem number 6, area under curve. So that on this test, we're looking at, which is the chapter 5 test, 1, 2, 4, and 6. On the test itself, 1 limit using graph, 4 limits using functions. Of all the derivatives, I'm choosing 5. 1 absolute maximum problem. I think you only circled 2, but there's going to be 1. 1 maximum, minimum, increasing, decreasing, concave up, concave down, inflection point. 7 integrals. 2 integration by parts. 2 improper integrals. And 1 area under the curve. You can use your formula sheets that we've used on previous exams on the final. No reason why you can't. Most of you don't need them at this point. I'm setting up the first final, and I'm going to reword this, for Wednesday the 12th from 11:55 to 3, because some people need to take it then because they're going out of town. So they want to take it Wednesday. So the first final will not be available. Well, I can make available before that, but the 6.1 quiz. Matt, 6.1 quiz, are you talking about more? Okay, yeah. And if not, we can do it tomorrow. I'll be sending out that paper. Yeah, I've got what I have to do is see, I'm still writing on it. So as I go over it with you, I'm making sure that all the information I'm giving you, I've updated it. I did the first update. Okay. Then I'm doing another final exam review. And that final exam review will be kind of like a mini test, but not a mini test. So I'm structuring it similar to your test, but I'm working on that right now. So in other words, I'm taking an old final and restructuring it. Won't be all of the problems that's on the final, but it'll be enough of a mix so you know what kind of problems you're going to be running into. But like I said, I'm only on chapter 3 right now. So I've got these 2 chapters to do and to key it. I should have that done sometime today. Send that out to you and hopefully do a video of it as well. But yeah, we're going to review tomorrow. We're going to review Monday. We're going to review Tuesday. And if we need more reviews, we'll set those up too. Yeah. So anyway, if we do it at a regular time, this is the time that you would need to set aside for me, which would be from 11:55 to 3. Doesn't have to be May the 12th, but if you want to do it at a class time, that's the block that you need to set aside. So we'll talk about that too tomorrow as to what you guys want to do. Yeah, you got to work around your other classes. Some have been extended, some have not been extended, which means if they've not been extended, you're going to have final exams next week in your other classes, which run 2 hours or so, depending upon what your instructor does. Some classes have been extended, which means you're running the final exams the following week. So it's just a mishmash right now. We just need to get through this semester. That's why I'm willing to set up a 3-hour block anytime you just tell me when. And Canvas allows me to do that. Because I'm not watching you. So that allows me to do that. So essentially, I'm working on this, and then we'll clean this up. I want to make sure all of this is right too. So you know exactly that so instead of having 2 improper, do I have 3, or instead of 2 integration by parts, do I have 3? Right now, I think that's what I've got. I've got to take a look at the final again. I've got the first cut of that. So I'll have a lot of that tomorrow as I'm kind of working through. And I think we'll leave Matt's that problem you want to see done. I'm going to make a note of it, and its number, and then I can print it out and have it available tomorrow. That was a 6.1. Let me go back here. .1 number 3. And then Max, I pull it from your quiz. So it'll be the problem that you worked. Anybody else want to see anything else work tomorrow? Make that a priority. Yes, no? Well, if not, any questions? And then we'll call it a day. And then I'll busily go back to my other computer and work on stuff so I don't have to hang here. Nothing? Okay. If not, I will stop recording with the ladybug. So that'll all be set up for those people who needed the recording from the day because they couldn't be here. And I don't know how I deal with I think, with WebEx, so I got to figure out how to do that. Because WebEx is still recording at this point. Oh, I forgot to take the roll. That's okay. That means I have to go to WebEx and get it again. I keep forgetting. It's just a pain in the rear to do that. To take roll from WebEx itself. So I will see you guys tomorrow. If you have anything in particular you want me to present or to do tomorrow, email me and I'll include that in what we're going to do tomorrow.
So I got a few questions.
Yeah.
So you said there was 2 exams, right?
2 exams. You're only one final.
Correct, yeah, but is it just one test with 25 questions?
Is that what all those numbers add up to?
I mean, that's what you were saying earlier in class, how it's 25 questions.
If it's 25, it's 25. I don't know. 10, 11, 12, 13, 24.
24, okay. And then all these questions, I'm guessing they're going to be on one paper, right? One exam, one test.
Just like it looks just like your regular test.
Just more questions.
Just more questions, yeah.
Okay.
Yeah, looks like a regular test, only more questions. That's any difference.
I maybe kind of got confused when you were like taking out the exams, since you
Yeah.
had like 1 through 6.
In other words, what we did is we're creating a study guide. That means that one thing you don't have to study is finding the derivative the long way.
Thank
Because
you.
that's not going to be on the test.
Yeah.
One other thing you're not going to have to study is find the equation of the tangent line, because that's not going to be on the test. So and about all of these other kinds of things, anything that we didn't circle is not going to be on the test. It narrows down some of the things you'll look at and say, I know how to do, that's not a problem. That allows you to then to focus on where your weaknesses are.
Right, yeah. So yeah, I was looking at the paper with like the one that you're supposed to send out, and I knew how to do some, but I did have so in chapter 1, which was like my worst test, I think it was like the limits one where it's like on the graph and you're supposed to tell the like positive infinity.
Yeah, I've got one of those included on the practice thing I'm sending you.
Yeah, I was gonna ask if we could probably go over those in class, and then
I found a nice little graph. I've got it all set up. I just have to finish it. So, like I said, I'm through the first 2 tests. I should get through the other 2, and then as soon as I take a look to make sure that the problems work, so that I don't end up with the same problem I did, where I chose a wonderful little problem and then it fell apart, and it's one I would not have wanted to work in class had I done it in advance. So at which point I need to make sure I don't have any of those things included. And that it does what I want it to do, which is to be an asset, not a hindrance. And then I'll send that out, and included on that handout will be a problem finding limits from a graph.
Perfect.
That's already been included. Yeah.
All right then. So yeah, I'll see you tomorrow then in class.
Alrighty, dighty.
All right. Thank you so much.
Oh, you're welcome.
Have a good one.
You too.